I'm Martin Levy from Hurricane Electric, and I'm going to do something that they teach you a long, long time ago not to do, and that's run a live website in a presentation. But hats off to those people who built the network. It's working like a champ, so we should be fine. Okay, so we are live. Oh, the other thing that presenters always like to do is have people look up from their laptops and not multitask. Actually, look at the presenter. Yeah, that doesn't work in this industry. But I actually want you to look at your laptops. Why not just work along with me and try this? Why look up here at a website when in fact actually you could just bring this up on your own laptop? So BGP, and if you're in this session and don't know how to spell BGP, yeah. So bgp.he.net, I'm going to play along here, and I'm going to sort of run you through some of the features and some of the new features that we've added on this site, specifically useful to peering coordinators, routing engineers, salespeople, and a few others. So, you know, we'll do through this. So let me just start. You know, you can tell here what we can see is we can see where we are sitting right here at the conference. We're on this AS 24555, and this is the beginning. This is just literally a what's my IP address type listing. The fact that it came up V4 versus V6, interesting, but we'll ignore that for the moment. So I'm going to click on the AS number, and one of the things you're going to see up at the top here is that you can just go straight for the URLs. bgp.he.net/AS24555, you're there. You're right at this. Interestingly enough, if you're running an internet exchange and actually have a list of AS numbers, feel free to link to this page. We're more than happy to see you do that. So here we are with a, oh, this is not a Mac. Here we are with a simple listing that is going to give us an idea of what this AS is. At the moment, the AS is registered in Australia. Seems to make sense. It's originating a couple of prefixes, one for V6 and one for V4. And it's seen via two links. So quite quickly, I'm going to go over to the graph page. This is sort of the more interesting page. I so want to use this like a Mac. So what we can see here on this graph is how the routes are propagated from this AS number. And immediately, we have two useful things. We have the fact that there are two upstreams for this particular AS. This particular AS doesn't have a lot of peering, or doesn't have any peering because we're not next to a peering point here. So if it was a peering AS, we'd see a lot more links, and we'll look at a few in a moment. But we're starting to see that there are two connections out of here. And by the way, different thickness of lines. And those line thicknesses, the part that's right here and below, is a measure of how many places we see a particular route or a set of routes from that AS propagating. So it sort of gives you an idea. But, in full respect to Randy, and that's not Randy Whitney down there, but Randy Bush, this data is coming from RIS at RIPE and from Oregon Route Views. So the information is only going to be as good as the routes that are fed into those collectors around the world. And a lot of people have come to me after playing with this tool saying, my AS number doesn't quite look right. A big network. And I go, well, are you feeding any route view in any form, in any way? And if the answer is no, then the routing that's seen here, or any other tool related to visualizing BGP, will simply be as good as somebody else's network sees that network. So this actually isn't going to look too bad, but there is no claim that this is 100% correct. It's just that most stuff that shows up here, if not all stuff that shows up here is there, there'll be stuff missing. So mouse over the AS number, and we see that this big amount of connection comes out of the first connection here, which is SIFI. The second one down here, we mouse over and we see that 4755 is Tata, the VSNL network. And as we go down here, we start seeing these bubbles of all of the other connections as they propagate through that. This is actually a pretty nice, simple diagram. But I'm going to pick on somebody, and I'm going to pick on Tata, and I'm going to click on that one, because there's actually a good reason for doing this. You'll notice that the graph actually can be a little bit more complicated. In fact, actually, it can become extremely complicated. But what we're seeing here is the fact that in the BGP world, life is complicated. And as a provider, think about using a tool like this to really understand not just who you're connected to, but how those routes propagate out and flow through the network. We could talk about this graph a little interesting. We could talk about some interesting leaks that show up here. But I'm going to go back to our network here and show you the rest of what's available. So if we look at the V6 graph, it actually looks a little simpler. In fact, actually, it's much simpler because there's only one upstream that seems to be seen from Tata, the VSNL network, which then goes into Tata, the global network, and then off to the rest of the internet. So this graph here is actually very simple because there really is only one V6 upstream. If there is a V6 connection to SIFI, none of the collectors have seen it. Doesn't mean it doesn't exist. It just means they haven't seen it and therefore can't be displayed. Some of the other information that you get out of this site, this is a nice easy one, of course, a list of prefixes. Now this is a simple list of prefixes. It could be much bigger than that. So let's go find a network where there's a much larger number of prefixes, and we'll go pick, again, very simply on VSNL. So now, whoops, now we can actually see that here's a list, a large list of prefixes. We can see the deaggregation, if it exists. We can see the major links that are there. I can keep scrolling this. Everybody here will start getting a headache. But again, play along at home. Bring up your own AS. Have a look at this. And talking of bringing up your own AS, let's do it. AS 6939. That's Hurricane Electric. Well, it'd be really nice if I spelled correctly. A simple query, a simple search will give us an AS number directly in there. Again, we have, sort of larger numbers here. We've got a graph that is going to look, slightly different. But actually, I don't want autocomplete. Stop that. But I'm going to go hit prefixes, and I'm going to show you something else that we've just added recently, is that on this site, now when we look at the prefix list here, you'll see a couple of the prefixes have got a green key next to them. That's the beginning of showing ROA information from the RPKI database. So we're taking the RPKI database out of the 5 RIRs, and we're mapping it against routes that we see globally. And if we see a match, a valid match, then we pop up a green key, because green is good. I'll go search for some red keys and some networks that aren't that good, but we'll talk about that later. Raf and Yarob were talking about the IRR databases. You can go get the IRR database out of this as well. There's many other places to get it, but it's just there for completeness sake. So let's go back and look at some other stuff that we can do here. Prefix reporting on the whole of the internet. There's a whole set of reports here. I'm not going to go through them because this is easy stuff to do. But these will give you, over time, how much information, how many routes we've seen. We can look at peer reports, which gives us a breakup of various different backbones and how they're connected. Again, from a BGP point of view. We can look at bogons. Now, this is sort of an interesting topic in itself. Go look at your own AS. See if you're announcing any bogons. See if there are routes that just are not registered in the RIRs. They're not allocated by a RIPE or an APNIC or an ARIN or whomever, and yet they're being announced from your AS. We can actually look at them, look at the V4 side of this here, and there's a whole bunch of routes there. Look up your AS, decide which way it is. You can look it up by prefix or by AS. But what I like is this page. This definitely shows that V6 is far, far behind V4. There are no V6 bogons at the moment. There were some, but at the moment that page is nice and clean. When you've got a routing table that's only 9,000 elements long, although it's growing, you can go after people if you see something incorrectly routed and find the person and fix it. When you've got a routing table that's just shy of 400,000 routes and a lot of bogons, it becomes much harder to do that. Let's hit a couple more, because actually this gets more interesting. So we also do a world report where we look at all the ASs from different countries. We're here in India, so let's jump directly to the Indian report here. And what we now have is the ability to pull out, again using RIR data, all of the ASs that are allocated inside a particular country. We're here looking at the India page. If you're from somewhere else, look at your country code. Again, the URL you can go straight to, country / and a two-letter country code. In this case, we've got all the usual players at the top. We are sorting them by adjacency. Why are we doing that? Well, it's because we're BGP guys, and adjacencies are sort of the lifeblood of BGP. But we could also click on one of the columns and we can sort it by routes, which really is a measure of deaggregation in some cases, so maybe that's not as brilliant as it could be. We can obviously look at the number of V6 adjacencies and click on that, and sort of and do this all different ways. So we can pick any one of these networks, and we can start looking at them. Take this as an exercise to do offline. You don't need me to go through it. But trust me, you can get some pretty impressively messy network diagrams out of this. And the reason you do that is because, well, I'll explain. We're going to pick a different country, only because if I pick on somebody here out of this region, they'll get annoyed that I didn't pick on their competitor. And we're going to go down here. I'm sorry, actually, I'm not going to do Mexico. Let's do Colombia. So, why Colombia? Actually, that's a good question. Why Colombia? So we'll pick Telmex. When we look at the graph for Telmex, this is far more complicated than we saw before. And why is it more complicated? If I've got the magic, yeah, I've got the magic green dot here. Hopefully this still works. So what we have here is we have a provider, it doesn't matter who it is at this point, who has multiple upstreams, yet it seems that they have multiple paths. This area here is getting quite complicated before we start hitting other tier 1 backbones and actually getting down to the end node. Why is that? Well, the reason is actually quite simple. This particular network announces an enormous number of routes. Well, a good couple of pages worth. And those routes may well be traffic engineered through different upstreams on this diagram. What this diagram is showing is a complete overlap of all of those routes on every direction. So it's going to be messy. If we were looking at a single route, it may be a very clean diagram, but this gets messy. And one of the things you have to now think about is traffic engineering by route announcement and deaggregation a good idea? Is having a messy diagram or a clean diagram a good idea? That's sort of outside the scope of what I want to talk about. But I wanted to point out something when I showed you the prefixes. Look, we've got nice green, we've got a /16 here, signed by Telmex, signed by AS, by that AS 14080. That's pretty good. That's actually really good. So let's look at another page. Let's look at the peers page. The peers page here, which is not too long, is really the definition of peer in the BGP sense of the word. An entity to which you are swapping routes, withdrawals and announces over BGP. And what you're going to do with that is you're going to say, this doesn't mean a peer in the peering personal sense of the word. It just means somebody that you have a BGP relationship that can be seen globally. And these networks here start showing up as the upstreams and also start showing up as the customer base. I told you this would be useful for a salesperson, but I'm not going to go and explain that any more than what I've already said. But the interesting thing here is I'm going to pick Telmex Colombia, one of the downstreams. I know it's the downstream. I'll explain why in a moment. And it's another part of exactly the same company. And Telmex Colombia, as he waits for the page to load, there we go, is actually a very simple network. If we look at it, the part that we can tell here is it is single-homed. It sits behind its parent network, and then the rest of it becomes a subset of that diagram we saw before. This diagram is calculated for each AS. It doesn't inherit the logic. But let's look at the prefix list. Why am I doing this? For those people that have spent time looking at RPKI, you'll realize the interesting problem here. Telmex Colombia has a subsidiary that announces a whole bunch of less specific routes. Look at all those red keys there. You got a headache yet? You got a headache yet? So anybody doing RPKI work should actually realize pretty quickly that this is an interesting mistake, that the routes needed to be announced, or some large route needed to be announced by the parent, who obviously has the LACNIC registration, and tell the rest of the world that this AS is, the sub-AS is the announcer of this. Now, there's a subtle point here if you've thought about this for half a second. Why did you deaggregate so many routes when in reality you only have one upstream? I'll leave that as an exercise for the reader. We can do a few more other things on this. There are DNS reporting tools on here. The search is sort of rather useful from that. So we'll look up Spain as ES, and voila, here's the route name information, the v4, the v6 information, and of course anything can be clicked on. So let's look at a.nic.es, and here we are seeing that it is a particular IP address and a particular AS number, and voila, we now can go look at the graph for a particular route. I'll hit the back button a few times and go back to this. We also have obviously the ability to show some green tick marks here if we see good stuff when testing stuff. So obviously we're here in India, so let's look at how to use this keyboard. And really, this is sort of the last stuff I'm going to show here. There's a couple of IPs that don't seem to be responding, but the rest of it, we have a v4 and v6 column, so that's all good stuff. MultiOrigin Routes. We know this exists. This is horrible, but it exists. There's two things to see here. First of all, notice that 192, sorry, actually that's not the one I wanted to show you. Oh, I think we're clean now. I normally want to show people the 192, 168 announcements. But anyway, notice that there's now an ability to go look at a whole bunch of announcements that are coming out of multiple ASs. If you're on that list, work out why. Whether it's a hijack or a complete and utter mistake, that's up to you to decide. But there are quite a few different ways of looking at this. Obviously, we see in V6, we see this now. We see it with Teredo and 6-4, which makes sense. But we also are still seeing it from a few other providers as well. That's pretty much it. There are some other stats on the page. But one of the things I say is if you're debugging how your peering works, if you're debugging how your transits are handling your routes, if you want to look up, I mean, you can query on a whole bunch of things here, IP addresses and the like, then feel free to use the tool and use it in good health. Thank you.
Thank you. You have questions?
Hello. Just a comment. Martin, this is freaking cool.
Yeah.
I think this is, I know the information is available in other ways, but the way you laid it out, I think that's just beautiful.
Okay. I don't know if that's me or not. Yeah, for those people that didn't know why we did this, this is actually based on a whole bunch of code that's in-house, which we use literally so that we know what's going on. We decided it was sort of, about 2 years ago we wanted to provide this out to the rest of the world. And as I say to people, use it. If you've got ideas, tell us. We keep releasing more and more of the internal version of this. The graphs can all be colored up internally, and you can do a lot more work with them, but we've just let out the stuff that, that makes sense. We are rack and stacking more and more servers as days go by to handle the load on this. I consider that to be a good thing. So yeah, please do use it and link to it if you want to.
Hi, Martin.
Yes, please.
Christian Nielsen, Microsoft. Yes, this is a beautiful tool, and you are a beautiful person. That being said, do you keep historical data, and is that easy to access with this tool?
It's easy for me to access.
Okay.
Yes, so the answer is that we actually have kept all this data historically for quite some time, and I'm going to put a caveat on that statement for a moment. Yes, it actually takes a lot of compute power for us to go back and build up data from the history. That's life. If we did this historically outside the simple graphs, like a prefix report graph is a view into the history. The problem that we have with it is that it just becomes a lot more compute power that we would have to let out to the rest of the world. I've thought about the fact that maybe we should charge for it, and don't get me wrong, I'm a capitalist and I do like that idea, but at the moment it is what it is. The data this is based on, and this is probably a key point, the data that this is based on, because it's coming from Wright, RIS, or Oregon, the DNS data comes obviously from other sources, the RPKI data comes from the 5 RIRs. All that data is public. We're not actually doing this out of our own routing table. So it is all public. You could recreate it, but the user interface on this was really the idea was the big win. One last point about the historical stuff, which we've got asked about. This is at the moment set up to process routes once a day, because it really does take a fair amount of compute power. And so running it once a day makes sense. We could actually do this 2 or 4 times a day, but once a day seems to be right. And if you look at the bottom of any page, this says updated at 6:30 Pacific Standard Time. So think about it, it's ready early in the morning in California, and that's the whole point, is internally for us, it was ready for the workday so that we could come in and look at what happens. So if you make a routing change, don't expect it to show up on these graphs in 5 minutes. It may well have propagated in 60 seconds around the world, but in reality, it's not going to show up on these graphs for another day.
Any other questions? Thank you, Martin. Thank you very much.